Hello students, how are you? So let's see basics of shear force and bending moment diagram. So before moving to this chapter, okay, the problem solving, let us just understand what is shear force and bending moment, and very important part is the sign convention. Okay, so shear force, you already know that it's algebraic summation, right? Algebraic summation of loads, forces acting on a beam. So in a right or left direction, okay, right or left of the section. So you know the section, right? So section, when you go step by step, so your section can be here, like in between, if you say AC D, so any random loads I have taken here. So section can be between AC or CD or DE or EF or FB. So wherever we consider the section, so shear force is the algebraic summation of the forces uh, towards the left or right of the section. Okay, this is about shear force. And bending moment, when we calculate bending moment about this section, okay, so see that this section x6 is over here. So when bending moment about this section, if you consider your calculation from right to left, or if you consider from left to right, so say we are doing our calculation from left to right, okay, for example only, this is not a question we are solving, this is just to understand the concept of a bending moment. So bending moment, when I consider left to right direction of solving, so here there will be some reaction Ra. Okay, so I can write and say this is a distance x. So bending moment at x is equal to Ra into x. Okay, so this is how algebraic summation of moments of forces acting at the left or the right direction. Now very important part, okay, we will be considering this all the in depth. Okay, we'll go ahead and we'll see all whatever all these things when we'll consider any beam, that time we'll be clear about it. Now very important part, that how do we consider the sign conventions? What are the sign conventions? Okay, so a beam like this beam, you know that this is a simply supported beam. So for this such type of beam, this beam can be solved from left to right direction or from right to left direction. Okay, so this can be solved by left to right or right to left direction. So it's your wish which way you want to solve. But based on that, there are sign conventions. So say this is one section x x, and if your flow of calculation is from left to right, then in this case, the forces, whatever going in upward direction, okay? And if your flow of calculation is from right to left, then the forces coming in downward direction. So here flow of calculation is left side, left to right, or here right to left. In this case, this is positive. Okay, this is positive. Now how do you understand this? Say very simple, let's take very simple question. So this is our simply supported beam. So one is hinge support and one is roller support. So in this case, say there is some load acting over here. Say this span is 2 meter, 2 meter, 1 meter, and this is A, B, C and D. Okay, now when you do the solution, if I am considering left to right, okay, so let's go like this, our flow of calculation like this. So initially we will be calculating reactions. Okay, so let's say 10 kilonewton load acting over here, 10 kilonewton load acting over here. Okay, so with this first step is to calculate reaction. So when we have to calculate reaction, we always have equilibrium conditions considered, right? So we have three equilibrium conditions to solve this problem. So we do summation of forces in y direction is equal to 0, summation of forces in x direction is 0, and moment is 0, right? uh, okay, now we can say Ra plus RB is equal to, the upward direction forces are positive and downward direction forces are negative. So we can write this equation as, let's say reaction at A is RA, reaction at B is RB. So 10 plus 10 is equal to 20 kilonewton. Okay, so this equation we have, let's call it as equation number 1. See, just to make you understand sign convention, I am actually solving this problem. Okay, it's a simple question we have taken. We are going to solve many more questions. Now, when we consider moment about any support A, okay, let us use the next sign convention. Here also we are assuming that clockwise movement is positive, okay, and it's absolutely up to you. You can even consider anti-clockwise movement is positive. Now when we consider clockwise movement is positive, that means at this particular point A, load into perpendicular distance. So if you see this particular load, it is making clockwise rotation. Here also it is clockwise, and this is making a anti-clockwise rotation. Okay, so on that basis, let us write down the equation. So 10 into 2 plus 10 into this perpendicular distance is 4, and this is clockwise, so positive, and this is anti-clockwise. So minus RB into 5 is equal to 0. So in this case 20 plus 40 equals to 5 RB. Therefore we can say RB is equal to 60 by 5. So we get 12 kilonewton as a reaction. Okay, so this is 12 kilonewton. So if this is 12, means this is 8 kilonewton. Okay, now I was just showing you sign convention, but I have solved this question because I wanted to know what is the reaction over here. Then only we can go for this shear force thing. Okay, now my way of calculation, I have decided to go as left to right. So later when you consider any section XX here, okay. So when you are going our calculation, so what we are doing, we are considering any section X here. So now you see the force going upward direction, okay, force moving in a upward direction. So as per sign convention, I told you, when your calculation is like this, so the upward direction force is positive. Okay, so that's how we have to understand that this particular sign convention, when your calculation is like this, left to right, so upward direction force is positive. Now let us consider the section like this here at this point. Okay, and we are going like this now. Okay, this is just in one question I am taking, but we don't do like this. Okay, this is just to understand the sign convention. So if you consider section like this, and if your flow of calculation is from right to left, okay, we are seeing this particular force from right direction to left direction. So in this case, this RB is going in upward direction, right? So RB is going in upward direction and section is XX. So what it will be? It should be positive or negative. So if you see here, this section XX, okay, and the downward direction force should be positive, but this is going in upward direction, okay, so that makes it negative. So there is one more sign convention, means opposite to this we can do. So I'm writing it here. This is section XX, and there is one force. So I'm just writing opposite to this. It is going upward direction positive now, so downward direction will be negative. This is downward direction positive, so upward direction will be negative. Okay, so this is the case of this gives us negative sign convention. Okay, so we are seeing here, we have seen shear force, sign convention. Okay, we have seen sign convention for shear force. Similarly, for bending moment, our sign convention will be so for bending moment, if you take like this, so this is positive. Okay, again it depends the way of calculation, flow of calculation, how do you take it. If you go left to right, then clockwise positive. If you do your calculation from right to left, then anti-clockwise is positive. Okay, so remember this. Then similarly we can write this is negative. Okay, so it is left to right if you go, and this is right to left. Sorry. Okay, so this is about sign convention of bending moment. There is one more thing. So if you see, this is actually making a sagging shape. So whenever there is a sagging, so we also consider it as positive. And if it is like this, it is making a hogging shape and it is negative. Okay, so this is about sign convention. Okay, sign convention of shear force and bending moment, and how do we understand it? Okay, so whenever we do the algebraic summation at the right hand side or the left hand side, so that is a shear force, and when we consider moment of forces about that section, so that is a bending moment. Okay, so this is very basic, and yes, I think you must be aware about the types of beams. So types of beams, we have. So this is a simply supported beam. Okay, one support is hinge support and the other is roller support. This is called as simply supported. Then there is a cantilever beam. This is cantilever beam. Then there is next beam, which is overhanging beam. So simply supported beam only, but there is some more extension. Okay, so this is called as overhanging beam. Then there is a fixed beam. So if you see the cantilever beam fixed at one end, then this fixed beam will be, but this is not for the, when you study strength of material, we don't go for this. Okay, it becomes a indeterminate, that we'll see in some other class. Okay, so there is a continuous beam as well. So if this simply supported beam, okay, if you see this, so continuous beam can be, a fixed beam can be, further extended to make it continuous beam. So that is also possible. So when number of supports are there, so this becomes a continuous beam. Okay, more than two supports are there, so it becomes continuous beam. And there are many more types. Okay, a beam can be with internal hinge also. There are various types of beams. Then there are different types of loads. Okay, there are different types of loads. So if we see types of loads, so on this beam, when a load is acting, okay, on this beam, if a single load is acting, so we call it as point load or concentrated load. Okay, when the load is like this, whenever load is shown like this, so then it is uniformly distributed load, and there can be a triangular load like this. It is called as uniformly varying load. Do you remember what I said just now? Okay, so this is point load or concentrated load. Then there is uniformly distributed load. Uniformly distributed load. And then there is uniformly varying load. Uniformly varying load. Okay, so here you can see it is continuously. Okay, there is this load, uniformly distributed load, it's continuous load. And this uniformly varying load, it is varying from 0 to whatever W maximum. So let's say this W. then this uniformly distributed load, it is also W per unit length. Okay, so it can be Newton per meter, Newton per millimeter, kilonewton per meter, and this load is always in Newton or kilonewton. Okay, so these are a few types of loads and types of beams. So in this class, we have just seen very basics of, what is shear force, bending moment, the basic definition, and what is the sign convention, which is very, very important, and the types of beams and loads. Okay, in next class, we will be starting with simple questions on shear force and bending moment. Okay, thank you students for listening to me, and if any questions, you can mention in chat box. Thank you.